our next equation. So when you're watching this, it stopped recording, so this is part 2 of the same lesson. So x squared y minus y dx equals cosine x, and our job is to find dy over dx. Alright, so again, this is an example of an implicit equation. We got y's in a couple different locations on our problem. Alright, so number 1. Colin, was the first step if I'm doing implicit differentiation?
Okay. I don't remember from yesterday.
What have we done first in our other questions so far this morning?
We got like find the derivative.
Yeah, so I'm doing the derivative, or I'm doing the differential of the original equation. Now notice in the original equation, both of the original pieces have 2 different parts. So I have to do the product rule twice on this original equation. Let's begin with the x squared y. To do the derivative, or to do the differential, I begin with the first term, which is x squared, and then I put the differential of the second term of our y. So what is the differential of y?
X squared dy.
I just have dy. So I kept the first term, and then the differential is dy. Now, notice this piece is not behind a minus sign, so I don't need to be using parentheses here. I'm going to have to do that when I go to the second part of the question, because that's behind the minus sign. So I'm going to put in our plus of the question, and now let's rotate. I'm going to do the second term, which is the y, times the differential of the first. So let's begin with what's the derivative of x squared? 2x, and then because I'm doing a differential, I'm going to put 2x dx. Now I'm going to put that in parentheses right now, just because I have that number there, so I'm going to be able to move that number to the front in just a second. I have my minus sign, and just like we've done in the last couple examples, because of the minus sign, and I have a product that is behind that minus sign, I need to use parentheses to help me on the second part of the question. As I go to do the differential on the second part of the question here, I begin with the first term, which is y. Then I take the differential of the second part. What is the derivative of e to the x? It is e to the x. And what do I need to include for the differential? dx. So I have y e to the x dx. Then I got my plus sign. And I'm going to rotate. I start with the second term, which is my e to the x. Then I put the derivative, or the differential of the first. What's the derivative of y? The derivative is 1, so then I would just put the dy, like you said up there, Colin. If I can get this thing to right, it's not cooperating whatsoever currently. Alright, this thing has quit on me. Let's just write off the doors. Josiah, come here, because you were good at putting that back the other day. Can you put that back for me, please? Can you get me on video for a second, Josiah? Thank you, sir. Alright, so we are currently sitting at x squared dy plus y times 2x dx minus, and we are at y e to the x dx plus, and that's where we stop. Okay, so we did the second term, which was e to the x. The derivative of y is just 1. And then we have our dy. And let's go to the right side. Alright, so right side is cosine. What's the derivative of cosine? Negative sign. So I have negative sine x. I'm doing the differential, so dx. Alright, again, I'm just going to neaten this up a little bit before we go to step number 2. I'm going to move this coefficient out in the front, and I'm going to distribute this negative in. So I have x squared dy plus 2, and it really doesn't matter the order of the variables. I'll just leave it as yx in the question, and then dx minus y e to the x dx the minus got distributed, so minus e to the x dy, and then the right side is negative sine x dx. Alright, so that was step 1. We did the differential of every single piece. And what's step number 2 want me to do?
Divide.
What am I going to divide by on this question?
Dx.
Dx, because that's what's in our denominator, so I'm going to divide every single piece here by dx. Alright, so let's see what happens. I don't have a matching piece here, so that stays as x squared dy over dx. I do have a matching derivative here, differential, so the dx's cancel out, and I'm left with 2yx. Once again, I have the matching pieces, those cancel out. I have y e to the x. They don't cancel here, so I still have the e to the x dy over dx, and they do cancel over here. So I have the negative sine x. Alright, Josiah, what's next?
You want to get your pieces with dy over dx together, so
Okay. So they're already on the same side. They're both on the left currently.
you can subtract out the 2yx over and then add the y to the x over.
There, so get rid of anything over here that doesn't contain what you want. Okay, now you guys gonna be okay if I do the factoring at this point of the question as well? Instead of writing down again and then factoring, I'm gonna do that because they both have dy over dx. I'm gonna yank that out. We're here on the left side of the question. That will leave us with the x squared and then the minus e to the x. The right side has 3 different pieces. They can come in any order. I have the negative sine x. We subtracted the 2yx and the y e to the x. What's my last step here, Amelia?
Divide x squared minus dx.
Very good. So divide by x squared e to the x. And there is my answer for the derivative with respect to x. Any questions on what we've seen so far with implicit differentiation? I'm going to wait on something for tomorrow. I'm going to have you practice 1 or 2 things out of the book in the few minutes we have left before chapel. Tomorrow, once we actually get the derivative, like we've been practicing the last 2 days together, remember what's the definition of the derivative? Is the slope. Well, in order to calculate the slope on one of these questions, they have to give us a point. Because a point contains an x and a y, and notice all of the formulas that we've written the last 2 days together have x's and y's. So we're going to see after we calculate the derivative tomorrow, how do we correctly fill in the point to actually get to the slope that we have on a certain portion of our graph. Alright, so what I'm going to have you guys do real quickly here, let's go to our lesson 34. Just do this in your notebook, or if you want a new sheet of paper, that's perfectly fine. On page, so we are on page 186. Let's see if you guys can do, let's go with question 3. See if you can do question, actually, let's think about that. Let's actually try, yeah, let's go question 3. That one looks good. So page 186, see if you guys can do question 3.